Going on to another interesting relation called the transitive relation now, where quite different from the cases which we already covered. The key difference is that here we are dealing with three ordered pairs or relations uh, between three ordered pairs instead of two. So let's go on to the particular relation now. So consider a given set A, then a relation R on A is transitive if A, B, that's two elements of the ordered pair is an element of the relation, and B and C is also an element of the relation, which implies that AC is an element of the relation for all A, B and C elements of A. Now, not the point that we are dealing with a single set, and here now a relation, we know that when a relation or a link up is based on the particular property, and when we are saying that if AB and BC are part of the are elements of a relation, then the first component of the first relation is pairing up with the second component of the second relation to form a third ordered pair. So this simply means that we surely are dealing with a common property, and by which all the three ordered pairs belong to a single relation. Now, also note the point that we aren't writing R1, R2, R3, R, which means that we are dealing with the same relation. It means that for our relations A are B and B are C, a transitive relation means that we end up with A R C for all A, B, C are elements of A. So what's the key property? What is the point which you should be remembering? Now, consider a set A having elements A1, A2, A3 to AN. Now, why can't I write it like A, B, C, thing like like that? The point why I have written it as A1, A2 is to indicate a common property. So here all the elements are having something common between them, and that's why a relation or the ordered pairs, that's why when they are pairing up in ordered pairs, we can get a common relation. And also note the point that if such a thing is possible, it means that you can arbitrarily choose any element. That is, you can choose A1 AN or A3 AN, or suppose there are 60 elements, then you can choose A40 and A60 or any ordered pairs you can choose. There's no problem in it. So what I just told is that so when they form ordered pairs, a common property, a common link up can be applied. Suppose you are dealing with a relation where the ordered pair is A1, A2, and another relation. Of course, it's the same relation. That's why it's not written R2. Where we have the two elements A2, A3. It simply means that because of the common property, across the elements involved, or across the elements which are forming the ordered pair, you can pair up A1 and A3, which also forms part of the relation, and that's a key point. Now let's look at a simple case to get a clear idea. Take Z plus, which is the set of all positive integers, and you are looking at a relation X, R, Y, and as underlined in the yellow line, now that's the key property is X is less than Y. That's the element X should be less than Y, and not that we have taken the elements X, Y, Z. That is it's the value of the element. So it indicates that the elements are in an ascending order, which simply means that we know that as positive integers are concerned, as plus 1 plus 2 plus 3, it simply means that the value of the elements are increasing. So it's that's another implication, or that's another inference. So if you look at this particular property across the elements of the set of positive integers, you can easily see that less than an element being less than the next element can be applied across all positive integers without any problem. So that's a key point, which simply means that x is less than y and y is less than z, which simply implies that x is less than z. That is x are y and y are z, which implies that x are z. Now what about we just discussed about positive integers. What about the set of integers, that is set itself, that is set of integers, that means negative and positive integers together. Now if you look at the number line, you can see that once again we are dealing with the elements with the increasing value, and I have arbitrarily chosen 3 elements, that is x, y, z, having values -3, 3 and 6 respectively. Now as we can very easily see, -3 is less than 3, and of course 3 is less than 6, which simply means that, which implies that -3 is less than 6. So if -3 and 3 forms a relation and 3 and 6 forms another relation, then naturally a third relation can be easily applied, which includes the ordered pair, or which is of the ordered pair -3 and 6. Thank you.